Hello, everyone. Good evening. I hope everybody is with me here. So let's wait for like a minute. Apologies for joining a bit late here, guys. So we were having some technical challenges. I was just trying to rectify that. Hello, everyone. Good evening. Great. So I think we are good to start. Thank you so much for being with me. And in our last discussion yesterday, we were talking about what is data science, right? So in the last discussion yesterday, we were talking about what exactly data science is. So today, we are going to take a step ahead and we're trying to understand what is artificial intelligence. So we understood data science is basically a bigger umbrella where we had a discussion about what all different concepts are there, what all different things you need in data science. And now, after the life cycle of my data science, we are trying to understand what is the another subsection of my entire bigger umbrella of data science, and that is going to be artificial intelligence. Again, one of the buzzwords, guys, around, and we need to understand what is artificial intelligence, what this video is going to be focused on, and we're going to be talking about what is artificial intelligence. So I will be giving you a brief about artificial intelligence, what all different areas, what all different things you're supposed to know in artificial intelligence. As always, anything which you want to discuss, it's pretty much a live session. So you can put up your questions or things in the chat. I'll be more than happy to take it and we can discuss on it likewise. So with this, guys, let's start our journey. So we are talking about artificial intelligence. So on your screen, you can see introduction to AI. That is basically what the agenda of today's class is. But before that, I would like to quickly introduce myself and I would like to tell who am I, what I've done till date and why I'm here. So, my name is Arpit Jain and currently I'm a lead data scientist myself. And the reason why I'm here, because data science is my passion and I really love sharing my expertise with people. That's what I really admire and I do it on my own interest. So about my profile, I have around close to 9 and 10 years of experience. We've been working into multiple different sectors, including banking sector, finance, cloud domain, manufacturing, automobile, telecommunication. So I've seen the industry grown and I've seen how data can do wonders in not only one sector, but in multiple such sectors. And I'm pretty much well versed with multiple skills which you can think of, data science, which includes statistics, machine learning, deep learning, and along with the engineering aspects as well. And I'm currently working as a lead data scientist myself. So that's a brief introduction about myself. And again, along with this, I'm also a motivational speaker. So I take up industry sessions. I talk to students regarding their career, job, placements, or anything, guys, anything in general also. Please feel free to reach out. Always happy to help. And I'm able to see the chat. So we are pretty much following up the chat. Any questions, anything in general, please let me know. So shall be happy to take up this. Cool, guys. So with this, let's start with our today's discussion, which is what is artificial intelligence? So primarily, we will be focusing around the data science. And in this data science discussion, we are going to talk about artificial intelligence. So what exactly artificial intelligence is? What are we expected to know in this artificial intelligence and how are the things in artificial intelligence? So that's pretty much what the agenda of today's class is. So here in this artificial intelligence, we will be discussing about the numbers, but you should be knowing, and I was also discussing about this in our yesterday's stream when I said it's about the data at the end, right? So at the end, what matters is the data which is going to give you some actionable insights. So in the end, you should only measure and look at the numbers that drive action, meaning that the data is the one is going to tell you what you should do next. Very famous proverb and exactly what mimics the requirement of data science as well. So in the data science industry, we always talk about the numbers, the data, right? So artificial intelligence is one of those sub branches, one of those pieces where we will be using this data in some or the other respective manners. But even before that, what primarily you should be understanding is the data. And if you remember, I was also talking about this in a yesterday's class. So data primarily is of two types. We talk about qualitative data, we talk about quantitative data. So how exactly we are going to use my qualitative information as well as my quantitative information. So qualitative information is nothing but where we say something which is in the form of proverbs or something in the form of adjectives, like a definition of something, like a quality of something. Or when I say this is a good, or I'll going to hill stations. So all of this is a piece of information, but not in the form of a number. So things like this are pretty much being qualified under a qualitative data. And the things which are prominently a number, like weight of me or a height of somebody, or how long I'll take to reach some places, what is the overall geographical surface area. So anything at the end which is now coming as a number is my quantitative data. So now, how exactly this data is going to help us take an actionable insights? That's where the science of data comes into picture. We talked about that. And what do we mean by that, guys? So data, as I've told you, it was always there. So now, once we have developed the science to work around this data, that's what we talk about, how we can use this for our own purpose. So in this case, data is prominently going to talk about the information which is hidden right now, which is not explicit. And from this piece of information, our objective is get the actionable insights so that we can take some actions, we can help a business take some relevant decisions on top of that. And it could be anything, it could be prominently anything. So you can think about any business scenario, be it in any industry like a supply chain or logistics or manufacturing or automobile or telecommunication or healthcare or finance. You can think about an industry and data is prominently everywhere. It's now the science behind this, which is enabling a business leader to take a relevant business decision as and if it comes. Right? That is the reason why we are saying the data is the one from which ultimately we will be measuring and able to take some actionable driving points from that. So the data is the one which is going to tell us what is going to happen next. And on that regard, we'll now move towards the sub branch of my data science, which is artificial intelligence. So what exactly artificial intelligence is, right? So again, let's try to understand intelligence, which is artificial. So what is intelligence? What do you think of an intelligence? When you come across this keyword intelligence, what do you think this intelligence is? Think about it, guys. So this intelligence, what we talk about is nothing but a way in which we can do something, like an intelligence of somebody. So we talk about human brain performing some action intelligently, right? But in this case, we're talking about not the same, but similar actions, but it is an artificial intelligence. This intelligence is not real. This intelligence is not through a human brain, right? So this intelligence, what we talk about, which is not through a human being, rather a machine or some special computer systems which is going to do this specific task which a human can do, is prominently getting classified into my artificial intelligence process. So here, artificial intelligence includes the simulation process of human intelligence by machines and special computer systems. So this artificial intelligence is the one which is including any simulation process of human intelligence. So ultimately, what I'm trying to do here is I'm trying to recreate this human intelligence artificially. And who is doing this? Some machines or some special computer systems, which is now able to replicate this or simulate this human intelligence by some sort, right? So this artificial intelligence is basically going to be the simulation process of my human intelligence by machines and special computer systems. We're going to understand from this, right? That's prominently my artificial intelligence is. So examples here of artificial intelligence include learning, reasoning, and self-correction. Let's try to understand what do we mean by these three examples: learning, reasoning, and self-correction. So a human being is having a very fantastic intelligence or capability to learn, right? So whatever new things comes up, even if we don't know about that, we ultimately ultimately have the capability to learn, right? To understand what is happening inside, to have a kind of a connect so that we can understand what is this new subject. And not only one thing, let's think from a child perspective. When a newborn is there, I mean, the newborn does not know anything. The newborn is trying to understand, learn a lot of things, maybe as primitive as a language or as primitive as trying to learn how to walk, right? And when we grow up, we learn some activities, right? We try to go to learn some new sport activities. We learn driving. So all of these things, whatever new thing which comes up our way, we have a capability to learn, right? And that is something again which becomes a core part of artificial intelligence. So we are trying to make sure that we are able to achieve this learning capability in the machines or some special computer systems. They are able to learn. So learning is one of the very crucial examples of my artificial intelligence, where we are primarily focused on acquiring new skill sets. Or in terms of machines, I'm talking about any learning capability which a machine inbuilt does not have, but now it is able to learn on top of it. That is what, again, artificial intelligence will come into picture. Next, reasoning. Reasoning, again, very important. So this type of artificial intelligence where we talk about questioning what is right, what is wrong. I need to have a reason behind things being happening, right? So what is right, what is wrong? We have to understand things very clearly. And that is where, again, artificial intelligence, one of the examples, comes into picture. The intelligence is able to question what is right and what is wrong. It is able to identify if that learning has happened, how good my learning is. More like a reasoning on top of that, whether this learning is good or it is not that great, or we need some modifications on top of that. So that is where, again, we talk about a smart reasoning activity where we are able to understand or identify what is right and what is wrong for my system. Again, a very crucial or very critical example of my artificial machine, where we now say that we are trying to understand how good my learning process is, and even if we have identified something, whether this identification process is correct or not. So this also becomes very important here. So we again talk about my artificial intelligence in this regard. The third and the last example of my artificial intelligence, we talk about self-correction. Self-correction is again one of the very crucial methodologies where we say how good my machine is. We're trying to identify whether I'm able to see this part or my machine is able to identify this or not. Again, an important part. So where we talk about my artificial intelligence, this is again very important. Uh, just a minute, guys. I think I'm facing some issue here. There's some issue with my camera. Just a minute, guys. Just correcting it. Yes. So I think I'm back. Uh, just okay. So there was some problem, guys. Apologies for this. I just corrected that. Fine. So what I was talking about in my examples of my artificial intelligence. So very first thing was learning. Second, we talk about reasoning. Now we're going to talk about my self-correction. Again, very, very, very important part of my artificial intelligence, where we talk about how exactly we are going to use it for my self-correction activity. So now we have made sure that we have learned what is required for the machine, and we have also questioned whether that learning is correct or not. Next, if that learning is now incorrect, I have a capability to self-correct that wrong learning as well, right? Again, very crucial example of my artificial intelligence, self-correction. So all of these three are equally important: my learning, my reasoning, and the self-correction activity of my artificial intelligence. So all of these three are equally important for me. So we talk about learning, reasoning, and self-correction of my artificial intelligence. The next, we're going to talk about what is artificial intelligence. So it is nothing but an application of AI. Here in this case include speech recognition, expert systems, and image recognition and machine visions, and then a lot of other things as well. So application of AI, this includes speech recognition. Again, a very, very, very interesting example use case, guys. So in speech recognition, we talk about identifying the voices of different individuals, right? So a machine is able to distinguish between the voices of different individuals. So speech recognition, and in fact, whatever I am speaking, it is able to convert it into a text as well. So machine is able to read what I'm speaking, and then what I've spoken, that is being read, and we are able to convert it back to a text. So that identification of my speech recognition is also happening. That is where we talk about application of AI, also includes my speech recognition part. Next, we talk about expert systems. So expert systems, again, an important part where we talk about advanced machineries as advanced systems, which is able to identify the problems in advance. We're going to talk about in detail. Image recognition, again, one of the very interesting use cases where just by passing the images, my system is able to identify what it is. Lot many use cases can come across image recognition. You might have heard of very fancy use cases coming around, like a face detection. So from the CCTV images, people are now able to identify, okay, or able to tag whether that person is, whether what is this person's mood, sad or angry or happy, a lot of things. So with the help of the images itself, now I'm able to perform a lot of analytics on top of that. Pretty much an example of image recognition. Lot of fancy things which can be done. Machine vision, we talk about text recognition. So a lot of different things can pretty much come under artificial intelligence, guys. All of these are pretty much part of my artificial intelligence. So as I was talking about three things, artificial intelligence. So the AI programming focuses on these three cognitive skills. So we talk about learning process, we talk about reasoning process, and we talk about my self-correction capabilities. So what are these now, guys? So what are these? What are these different types of things? What we understand? So as I was talking about the learning process, very important. So this is for making the rules, aka the algorithms, to learn the patterns or info available from the data. Again, what does that mean? When we talk about the rules, the algorithms, is where now we are able to understand what is the right pattern or information needed for my available data. We are trying to understand how this is getting used for the identification of my available pattern. So we say the algorithms. So think it from a data perspective. I have a data set, and from this data set, we're trying to identify what all hidden patterns are there. And based on these patterns, we're trying to develop some learning process on top of it. Right? So learning is here, in this case, artificial intelligence. So whatever data points we have, we're trying to establish the network connection, or we're trying to make up the rules or the algorithms based on which the learning can happen. Right? So the algorithms which is used to learn the patterns or the information available from the data. That is what we have the learning process coming from. We say that this is the for making the rules or the algorithms to learn the patterns or information from available data. Next, we talk about the reasoning process. So this aspect of AI programming focuses on choosing the right algorithm to reach the desired outcome. Again, very important, guys. So the learning process is where we talked about we're trying to understand and we're trying to define some ground rules based on which we can identify and learn the patterns available from the data. But this learning can be correct or can be wrong, or it can be done in multiple different ways, right? And nobody is sure of which way is right and which way is wrong, correct? So based on this learning what we have, now we're trying to reason our process. Now we're trying to understand which of the learning process is the ideal for me. So I'm trying to understand and trying to reason basically out of all the available methods which we have, which one is the right path for me. So I'm choosing the right algorithm to reach to our desired outcome. So there are a lot of important key things here, guys. So right algorithm. So this is the place where we have a pointer to kind of question if we are going into this direction, whether we are correct or not. So for this, first we need to have some right metric to compare. So ultimately what's happening here? So in the reasoning process, my artificial intelligence cognitive skills, this is focusing on evaluating different algorithms or different processes which we have in this learning. And out of this all available processes, trying to find out which one is the ideal one for me. Right? So this programming, AI programming, is focusing on choosing the right algorithm to reach a desired outcome for me. Again, one of the very interesting ways where we're trying to question the different strategies, the different algorithms. So basically what it does, so whatever different methods we have, different processes we have, it is trying to find out the pros and cons, and from the available data set, it is trying to map this pros and cons and trying to give me whether this one is correct or this one is correct or this one is better, this one is, I would say, not that great for this data. So this aspect of AI is trying to stitch together the multiple ways in which we can use the different algorithms or different rules to identify the patterns of my data and which one is the ideal one. Lot of comparison analysis, identification of my right metric, identification of my right method. That is where this prospect of AI focuses on. And also, if you can see, we talk about a desired outcome. So this desired outcome again is very subjective to my problem statement. Think about it, guys. Think about it. So For example, suppose whatever my problem statement is, you can think of, I'll take out very simple examples, layman examples, like every day-to-day life examples. Simple. You might have heard of cancer detection, whether that person has having cancer or not, right? So again, here we talk about a desired outcome, which is now in my problem statement, my desired outcome is to identify whether that person is having a cancer or not. A reasoning process. So my desired outcome here is to identify the right patients who is having the cancer. So that is my desired outcome. Likewise, I can think about some normal problem statements, like suppose I want to predict what will be the sale price of the cars the next year. So my desired outcome in this case is not whether the patient is having cancer or not, more like a yes-no situation. I'm not talking about a number, right? So depending on whatever outcome I'm looking at, it is able to identify which one is the right path for my learning process. And obviously, since we're talking about different pointers, different data, I can have different methodologies as well. And that is where this learning process comes into picture. And that is where we talk about a method or a process where the machine, the special computers, they are able to learn these patterns with these algorithms and also able to question whether which one out of these methods is correct or an ideal one. And my end objective is to reach my desired outcome, and this desired outcome is very subjective depending on my problem statement which I'm trying to solve. So that's prominently where we talk about my learning process. That's prominently we talk about my reasoning process. I hope it is getting clear, guys. So as always, I'm following up my chat. Any questions, please put up your question in the chat. More than happy to take that, guys. Next part of my cognitive skills of AI programming is my self-correction process. So as the name suggests, we're talking about a methodology where we are trying to create some self-corrections of my process, right? So how exactly the self-correction will happen? Think about it. So the moment we have created or identified multiple different processes, right? And the moment we have questioned which one is correct for me, and we identified, okay, this one is not right, or this one is still the ideal one, but we might need to do something else on top of this. So the self-correction process now is designed to continually fine-tune the algorithms and ensure they are going to provide the best results possible every single time. So what do we talk about here is, we're trying to understand, even if we have created this multiple correction methodologies, we're trying to say that out of this, how exactly we are supposed to do things where we say, okay, this is the fine thing, and based on which now I'm able to get the best results. So always having that self-correction methodologies in place, right? I'm trying to understand, is there a fine-tuned method, or is there a particular way in which I can make sure that my whatever algorithm, whatever method I have chosen, it is able to identify the errors or whatever wrong learnings might have happened, and able to take a corrective action so that the same problem does not happen the next time. So again, a very important programming, AI programming cognitive skill focus, which is towards my self-correction process. And here we talk about a method in which we are continually fine-tuning the algorithms and ensuring they provide the accurate results every single time. Again, a very, very, very crucial and one of the important processes of my artificial intelligence, self-correction. Certain advantages and disadvantages. So I'll talk about the advantages first. So in the advantages, we talk about very good for data heavy jobs. What is my data heavy job? So we always talk about big data, right? And we always talk about humongous data variation. So in data, we basically talk about variety, velocity, and veracity, right? So we always talk about how spread my data is, what is the different set of features, what is the variations in my data. We always talk about the different volumes from of data, like in volumes like in TBs or GBs. So all of this where we have the capabilities to cater the data heavy jobs. So my artificial intelligence processes is specifically designed to perform the very good operations for my data heavy jobs. Hello, Praveen. I just saw your text. Thank you so much for being with us. Right. So it is, again, as I've said, very good for data heavy jobs. That is where I say it is now prominently looking at the jobs which is data centric. Whatever the volume of my data is, whatever the different variations of my data is, yes, with certain fine tunings of my methods, with certain tweakings of my processes, the artificial intelligence is able to do this data heavy jobs quite neatly. Again, it is going to save time in my computation. Think about a process where I have a human being who is taking care of this learning process on its own. Do you think it is even practically possible? Right? So, obviously, this artificial intelligence, the mechanism in which I am trying to give this data heavy jobs and the learning process from humongous volume of data from machine, and it is going to save a lot of time because the machines are able to do this computation very fast, and that is where we are going to save a lot of time. Very good in terms of computational timelines compared to the rudimentary methods. Yes, consistent results. So we talk about a human errors and we talk about the machine errors, right? If the machine has learned something, it has learned it. It's more like an algorithm which the machine has identified. So there is no chance of human error as such. So whatever the learning has happened, we are going to replicate that learning right now, or maybe 5 years down the line, or maybe 50 years down the line. Yes, if the pattern itself will change, I might need some fresh learning for my machine. But considering my other external factors being constant, whatever the learning has happened, the same learning is going to get replicated in time in future without having any issues. My machine is going to give us the consistent result every single time I'm going to run this. It's a rule which the machine has identified, in short. Availability, we talk about availability of my machine. So it is always available. So there is no dependency of any sort here. So it is going, once the learning has happened, it is always available, giving us the consistent results. So availability again here is a very, very, very crucial thing, which an artificial intelligence where plays an important role. But yes, along with this, we do have certain strong disadvantages of artificial intelligence, because if you understand, we are talking about the computers, we're talking about machines, we're talking about special computers. So what are these? And that is where we say that this artificial intelligence is directly dependent on these, which is nothing but it is infra dependent and hence it is expensive. It is always dependent on my infra. If my machine itself is not that strong, if I do not have these special computers where I can do these learning activities, then I'm going to have nothing at the end. Think logically, right? So we are even in the definition I talked about this. So I'm trying to make some learning, and this learning is going to be happening from the machines or the special computers. And that is the reason why we are saying this artificial intelligence is pretty much infra dependent and hence it is expensive. Always. Artificial intelligence process is always heavily infra dependent, and hence since the infra itself costs a lot, it is expensive. Also, it requires technical expertise. It requires the additional skill to make sure that you can let the machine learn things, right? So that is where we have the additional skill sets which needs to be developed. We talk about artificial intelligence where we have machine learning, Python. So a lot of different subjects where we are focusing on inside the artificial intelligence. So yes, it does require certain technical expertise which needs to be answered. And that is where we say artificial intelligence comes along with a package, right? So we need to be very sure of what infra I'm going to run this machine on. And we are going to understand what technical expertise I need to run this. So very much infra dependent, very much required a technical expertise of my skill set. Without this, it is not possible to run an artificial intelligence thing. And also it is heavily dependent on data and nothing beyond that, right? So we are talking about the data and nothing beyond that. So it only expects data. And if I do not have a data itself, so I say about learning process, how does the learning happens? Learning is happening here through the data which I have, right? And in this case, if I do not have the data itself, how am I supposed to have the learning in place? So I need to make sure that I have the best availability of data, because my artificial intelligence methodology is heavily reliant on what data I have and nothing beyond that. So if my data availability has an issue, if my data quality is an issue, if my data volume is an issue, yes, this is going to affect my learning process, going to affect my artificial intelligence process. Again, a very crucial disadvantages where it is heavily dependent on data and nothing beyond that. So I need to make sure that I have the right sort of data through which I am expecting the learning process to happen. So question from Praveen. He says, I'm a student from Nepal. How can I get placement in the multinational company? Very good question, Praveen. So, okay. So to be honest, it does not really matter from which country you are in right now. So it's more towards understanding of the skill. So getting a placement in a multinational company, it requires the skill. So you have to first understand what role you want to get into, Praveen. So I believe since you're part of this discussion, so you're definitely looking towards artificial intelligence, machine learning, data science, somewhere in this part, right? So if you're looking towards this area where you have artificial intelligence or data science coming into picture. So you have to identify certain core skills, which we will be anyway be covering in our series, but I'll still tell you. So there are a lot of buzzwords you might be hearing like Python, statistics, machine learning, deep learning, whatnot, right? Tableau, Power BI, a lot of things are there. So to get a job first, I'm not talking about any specifically about multinational company. I'm just talking about a job, and it's valid for every organization, whether it is a multinational company like an MNCs or a mid-sized organization or a startup. It does not really matter. Okay. So you have to first understand, for getting a job in either of these companies, your prime requirement is your skill. You have to first focus on what skill you want to get a job on, whether that skill is basically I would say Python or a SQL or a statistics or machine learning, whatever your skill is. Based on that, you are going to acquire that skill, and then on that basis of skill, you will be getting the job. So you have to always give priority to your skills, and obviously, depending on the multiple roles, you will eventually funnel down the right set of skills for you. For example, like an analyst, so maybe we might need to put more focus towards Python, SQL, statistics, or maybe towards setting up a BI tool. Likewise, multiple roles are there, and each role demands certain skills. So you have to first focus on the skills and just forget this thing from your mind that an MNC requires something additional and some other company requires something additional. So more or less the companies are same. The processes might change from company to company slight bit here and there, but that you can always check it from your recruiter if there is something specific which you have to look at. But be very open towards that. So focus on the learning. That is where your skill sets become your prime entry point through which you will be getting your job. I hope that answers your question, Praveen. Cool. So with this, let's come back to our slide. So we are not talking about, we discussed about the different cognitive skills of my artificial intelligence. Now we are going to talk about the 4 different types of artificial intelligence. So artificial intelligence are basically of 4 different types, guys. We need to understand that. And all of these 4 different types has their own respective meaning. When, why, and what. So artificial intelligence here, as you can see, can be divided into reactive machines, limited memory, theory of mind, and self-awareness. So broadly, artificial intelligence is now getting split into 4 different types: reactive machines, limited memory, theory of mind, and self-awareness. Let's try to understand each of them one by one. So what are reactive machines? So these are very basic, and it perceives things as it's given to it. Very basic machines, and it is just accepting the thing as it has been given to it. So a reactive machine here, it does not have any memory, it cannot store a memory, and as a result cannot rely on past experiences to inform the decision making in the real time. So the reactive machines is more like on spot reactions. Here the machines do not have any memory. This is something which is very important. So we talk about the machines where we do not have any memory as such, so it cannot store a memory here, and as a result it cannot rely on past experiences. So no history is going to be used here, and once we are not going to rely on my past experience, that means that I am not going to have any learning process from my past, right? So reactive machines, they are not going to store any memory. They do not have any memory, and they are not going to rely on my historical data for any decision making in the real time. Yes, and that is the reason why it is directly meant that reactive machines are designed to complete only a limited number of specialized duties. So complete only a limited number of specialized duties. So reactive machines are specifically designed where we are only going to focus on certain limited number of specialized duties. It cannot perform a broad range of activities. It is directly meaning that the reactive machines are having limited operations because it is not going to have any past information. It is not going to use any past knowledge for any decision making. Whatever has happened, whatever is happening at that very moment, reactive machines is going to take an on spot decisions on top of that, and it is very reliable on very specific usages. So reliable and has very specific usages. For example, one machine is Deep Blue. It was more like an IBM chess program that actually beat Gary Kasparov in the 1990s. So Deep Blue was one of the reactive machines, artificial intelligence reactive machines. It was developed by IBM, and IBM for the IBM chess program. So it was specifically designed for a chess program by IBM that actually beat Gary Kasparov in 1990s. So, and moves here, so whatever the chess moves Deep Blue was taking, it was only happening on the runtime. It is not based on the past moves. Only on the runtime, the machine was able to take a decision. What next? So the machine was not prominently getting trained on some past historical data and only taking the decision on specific things on the real time. Yes, reactive machines has very limited operations, very limited usages, and wherever it is getting used, it is highly reliable in those areas. Right? The next, we talk about limited memory operations. So limited memory operation is slightly more complex and it can store the previous data and predictions. So an advancement over my reactive machines artificial intelligence in the limited memory, it is more complex and it has a capability to store my previous data and the predictions. And you can think of, if I'm talking about storing the previous data and the predictions, I'm basically talking about continuous training and the updated patterns. So the moment I have a data, now I can actually perform some actions on top of this, and I can make sure that if this has happened in the past, something similar can actually happen in the future as well. And that is where the concept of limited memory comes into picture. It is more complex, and we are talking about storing the previous data and the predictions. And as you can see, it needs continuous training for updated patterns. There are prominently 6 steps which is getting followed in the limited memory operations. First, we talk about training the data. By training, we mean, so whatever data we have stored, on that data, the training has to happen, the learning process has to happen. So that is where a learning comes into picture. And this learning is basically through the algorithms where we have the machine learning setups. So this is where we have the ML algorithms coming into picture. And once this ML algorithm has identified the right patterns, has learned the things and created a model, With this model, we can pretty much generate the predictions for future. And these predictions can actually go under self-correction methodologies. So we are going to take some external feedbacks for these predictions, storage of my feedback, and then repeating of my same operation. So depending on whatever the learning is, the feedback mechanism, I'm going to repeat the same task so that now in the next learning, depending on the feedback which we have got, we can now modify our learning results. That is where the limited memory operations comes into picture. So we're talking about now an advancement over my reactive machines, where we can now store my previous data and use the specified learning process to generate the smart predictions in future by having the storage of my previous data. And with this updated patterns, we are going to follow certain steps, build up the model, train the data, and generate the predictions, find out the feedbacks, and again retrain depending on the deviations from my predictions, depending on the feedback. Part of my limited memory operations, guys. The next is theory of mind. It is only conceptual. The research is ongoing in this area, theory of mind. Here we talk about should be able to grasp and process the concept of mind. This is very important. Theory of mind, we talk about human brain. So human brain is open. It is able to perform all possible action. I can walk, I can talk, I can jump, I can run, I can do every single thing. A human brain can do every single thing. And that is where theory of mind comes into picture, where the objective is to grasp and process the concept of mind. We are trying to now replicate or mimic the mind. It is still an ongoing thing. So only conceptual right now, it is an ongoing research topic. Again, part of my artificial intelligence. The last is my self-awareness. Again, in a conceptual, again, research is ongoing on top of this. But here now we talk about actions on top of theory of mind, mimicking my human brain. So I have identified there's an object. Whether I have to pick up that object or I have to throw that object or I have to cut that object, whatever it is, taking an action on certain explicit things what I have. Actions on top of my theory of mind, more like a robotic actions. We talk about my self-awareness. Again, a research field, ongoing field. It is where we are trying to mimic the activities of my human brain. Pretty much part of my artificial intelligence. So all of these four things, whatever we have learned, the types of my artificial intelligence, reactive machines, where we do not have a past history. We are only talking about spontaneous results, spontaneous actions, reactive machines. Second, we talk about the limited memory, where we have the memory, we have the storage, and based on those storage, a learning is happening. And based on that learning, now I'm able to take some feedbacks, generate some patterns, and again, doing the fine tuning of my results. The next we talk about theory of mind, more like having a self-awareness of what is around and how things are happening. And then we talk about self-awareness, where it's more like actions on top of theory of mind. So where we talk about how we can take certain actions or mimic my human brain. So both of these parts, theory of mind and self-awareness, is ongoing research topic in artificial intelligence. So researchers are still ongoing, guys. So this is broadly what I wanted to cover in artificial intelligence. So in nutshell, artificial intelligence is again subfield of my data science, where now we are talking about the different cognitive skills, which is prominently going to be used for my process of data. So how exactly I'm going to process the data, what are my different steps, and what kind of learning I'm going to perform, whether that learning is correct or not. And if that is incorrect, I'm able to correct that by using a self-correction methodologies. All pretty much comes under my artificial intelligence method. Cool. So with this, we are pretty much done, guys. Any questions, anything? I'm going to wait for like a minute or two. So any questions, please feel free to put up your question in the chat. I'll try to take up that question. But meanwhile, this is what the artificial intelligence talks about. And we are trying to understand how useful this is for our business. And in our next video, we will be now going deep into one of those respective applications in details. We will try to understand how exactly this would be used for our own data science purpose. So with this, guys, we are pretty much done with our today's video. And as always, thank you so much for joining us. I will again go live a day after, and we will be discussing one more topic, interesting topic towards my artificial intelligence that is going to be prominently on the one of the applications of artificial intelligence. Cool, guys. Thank you so much. With this, I'm gonna leave you. Have a good evening and see you a day after with a new set of topic, guys. Thank you so much for being with us. Have a good day ahead. Bye-bye.